ESP8266. The ESP8266 is a low-cost Wi-Fi microchip with a full TCP/IP stack and microcontroller capability produced by Espressif Systems in Shanghai, China. The chip first came to the attention of Western makers in August 2014 with the ESP-1 module made by a third-party manufacturer AI Thinker. This small module allows microcontrollers to connect to a Wi-Fi network and make simple TCP/IP connections using Hayes-style commands. However, at first, there was almost no English language documentation on the chip and the commands it accepted. The very low price and the fact that there were very few external components on the module, which suggested that it could eventually be very inexpensive in volume, attracted many hackers to explore the module, the chip, and the software on it, as well as to translate the Chinese documentation. The ESP8285 is an ESP8266 with 1 MB of built-in flash, allowing the building of single-chip devices capable of connecting to Wi-Fi. These microcontroller chips have been succeeded by the ESP32 family of devices, including the ESP32C3. Features. Processor, Lone 10632-bit RISC microprocessor core based on the Tensilica Extensa Diamond standard 106 micro running at 80 MHz. Memory 32 KB instruction RAM, 32 KB instruction cache RAM, 80 KB user data RAM, 16 KB ETS system data RAM. External QSPI flash, up to 16 MB is supported, 512 KB to 4 MB typically included. E802.11b/G/N Wi-Fi, integrated TR switch, balun, LNA, power amplifier and matching network, WEP or WPA/WP-ATWO authentication, or open networks. 17 GPO pins. SPI. Hey. I2C software implementation. I2's interfaces with DMA sharing pins with GPO. UART on dedicated pins, plus a transmit-only UART can be enabled on GPI-ATWO. 10-bit ADC successive approximation ADC. Pinout of ESP-1. The pinout is as follows for the common ESP-1 module. GND. Ground 0V, EURO-V, 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 EURO-V. Ground 0V, EURO-V. Ground 0V, EURO-V. Ground 0V, EURO-V, EURO-V. Ground 0V, EURO-V, EURO-V. Ground 0V, EURO-V. GPO2 general purpose input/output number 2. GPO0 general purpose input/output number 0. RX receive data in, also GPIO3. VCC voltage plus 3.3 V can handle up to 3.6 V. RST reset. CHPD chip power down. TX transmit data out, also GPIO. SDKs. In October 2014, Espressif Systems released a software development kit SDK for programming the chip directly, which removed the need for a separate microcontroller. Since then, there have been many official SDK releases from Espressif. Espressif maintains 2 versions of the SDK, one that is based on free RTOS and the other based on callbacks. An alternative to Espressif's official SDK is the open-source ESP Open SDK that is based on the GNU Compiler Collection GCC toolchain, maintained by Max Filippov. Another alternative is the unofficial development kit by Mikhail Grigorev. Other SDK mostly open source include Arduino, a C++-based firmware. With this core, the ESP82 ESP8266 CPU and its Wi-Fi components can be programmed like any other Arduino device. The ESP8266 Arduino core is available through GitHub. ESP8266 Basic, an open-source BASIC-like interpreter specifically tailored for the Internet of Things IoT. Self-hosting browser-based development environment. ESP-Easy, developed by home automation enthusiasts. ESP Home is a system to control your ESP8266/ESP32 by simple yet powerful configuration files and control them remotely through home automation systems. Tasmoto open source firmware, very popular with home automation enthusiasts. ESP OpenRTOS, open source free RTOS-based ESP8266 software framework. ESP Open SDK, free and open as much as possible integrated SDK for ESP8266/ESP8285 chips. Espressif, an actively maintained JavaScript SDK and firmware, closely emulating Node.js. Supports a few MCU, including the ESP8000. Esperna open source ESP8285/ESP8266 firmware. Forthright port of Jones 4th to the ESP8266 microcontroller. MicroPython, a port of MicroPython, an implementation of Python for embedded devices to the ESP8266 platform. Moddable SDK includes JavaScript language and library support for the ESP8266. Mongoose OS, an open-source operating system for connected products. Supports ESP8266 and ESP32. Develop in C or JavaScript. Node MCU, a Lua-based firmware. Platform I/O, a cross-platform IDE and unified debugger, which sits on top of Arduino code and libraries. Puna fourth inspired programming language for the ESP8000. SMING, an actively developed asynchronous C/C++ framework with superb performance and multiple network features. ULisp, a version of the Lisp programming language specifically designed to run on processors with a limited amount of RAM. Z Basic for ESP8266, a subset of Microsoft's widely used Visual Basic 6, which has been adapted as a control language for the ZX microcontroller family and the ESP8000. Zurant EOT framework for programming ESP8266 and other microcontrollers in Python. Espressif Modules. This is the series of ESP8266-based modules made by Espressif. In the table above and the two tables which follow, active pins include the GPIO and ADC pins with which external devices can be attached to the ESP8266 MCU. The pitch is the space between pins on the ESP8266 module, which is important to know if the device will be used on a breadboard. The form factor also describes the module packaging as 2x9 dial, meaning 2 rows of 9 pins arranged dual in line, like the pins of DIP-IC. Many ESP-20 modules include a small onboard LED, which can be programmed to blink and thereby indicate activity. There are several antenna options for ESP-20 boards, including a trace antenna, an onboard ceramic antenna, and an external connector that allows an external Wi-Fi antenna to be attached. Since Wi-Fi communications generate a lot of RFI radio frequency interference, governmental bodies like the FCC like shielded electronics to minimize interference with other devices. Some of the ESP-20 modules come housed within a metal box with an FCC seal of approval stamped on it. First and second world markets will likely demand FCC approval and shielded Wi-Fi devices. AI Thinker modules. This is the first series of modules made with the ESP8266 by the third-party manufacturer AI Thinker and remains the most widely available. They are collectively referred to as ESP-20 modules. To form a workable development system, they require additional components, especially a serial TTL to USB adapter, sometimes called a USB to UART bridge, and an external 3.3-volt power supply. Novice ESP8266 developers are encouraged to consider larger ESP8000. When project development is complete, those components are not needed, and these cheaper ESP-20 modules are lower power. In the notes column, flash memory size is applied to the given module and all those below it in the table. Exceptions which apply to a single module are shown in other boards. The reason for the popularity of many of these boards over the earlier ESP-20 modules is the inclusion of an onboard USB to UART bridge like the Silicon Labs CP2102 or the WC, coupled with a 3.3-volt regulator to provide both power to the board and connectivity to the host software development computer, commonly referred to as. With earlier ESP-20 modules, these two items, the USB to serial adapter and the regulator, had to be purchased separately and be wired into the ESP-20 circuit. Modern ESP8266 boards like the NODEM CU are easier to work with and offer more GPIO pins. Most of the boards listed here are based on the ESP-12E module, but new modules are being introduced seemingly every few months. ESP32C3. In 2020, Espressif announced a new chip ESP32C3, which is pin-compatible with ESP8266. It is based on a single-core RISC-V32-bit CPU with a clock speed of up to 160 MHz. It includes 400 KB of SRAM and 384 KB ROM storage space built in.